This is an AIPMT 2010 question based on concept of friction. The problem is like this. A block of mass M is in contact with a car C as shown in the diagram. Coefficient of static friction between block and the cart is mu. Acceleration alpha of the cart that will prevent the block from filing with how much it has to move so that this block won't slip down, right? That's the question, right? Let me redraw a diagram for you to understand what he is saying for you. There is a block, so there is a cart C having some acceleration. To that vertical wall, a block of M is attached. As you are trying to study, as you are studying M, C becomes its frame of reference. And the frame of reference is accelerating. When the frame of reference is accelerating, it is a non-inertial frame. Newton's laws of motion cannot be applied when the frame is a non-inertial frame. So to compensate that non-inertial frame on the block, we shall imagine a pseudo or else a non-existing acceleration. So to eliminate the impact of non-inertial frame on the block, let me imagine a pseudo acceleration alpha. This is not actually there, but this is pseudo. This pseudo force will be automatically M alpha. It is applied by block on cart. That's an action. Then the cart applies a reaction. As reaction, cart also applies same on block in opposite direction. That is called a normal reaction. So in this case, normal reaction is nothing but equal to M alpha. Now the weight of the block is always acting downward direction, and that weight pulls block down and try to detach from that cart. Now as that is trying to sliding down, a frictional force is developed against the motion. As the motion is sliding down, frictional force acts in a upward direction, right? So what we can say, that implies for block not to slide down, weight mg must be balanced by frictional force. That mg is frictional force is mu into normal reaction. We have already proved that normal reaction is nothing but equal to m alpha. M and m will cancel. So the acceleration alpha equal to g by mu, right? If acceleration is g by mu, the body is not going to get detached. Acceleration of the car. It could be, we don't have that option actually, right? Exactly equal option is not there. It could be even greater. Even if it is greater also, that's able to balance it. So alpha is greater than or equal to g by mu is the answer to solve this problem, right? So while solving this problem, we have learned one important concept, that the body that you are trying to study is attached with another system that is having acceleration. Then the body becomes a non-inertial frame, becomes staying in a non-inertial frame. To balance the non-inertial frame, because for a non-inertial frame we cannot apply a Newton laws of motion. On the body we shall imagine a pseudo force. That's what we have done, and we have solved the problem. Other part of the problem is as simple as the other part. As the body is trying to slide down, its motion is tend to move downward. Obviously friction opposes rate of motion, so that is upward. When both of them are balanced, the body won't slip. That's how we have to solve the problem. Thank you for watching.